Continuing section 8.1, we're talking about factoring trinomials where the leading coefficient is 1. So we're going to look at the constant, and we're finding all the factors of the constant, so 1 and 15 and 3 and 5. And then we're looking at the sign of the constant to tell us if it's a sum or difference. So we know we're looking for a difference, and sum or difference of whatever this middle term is. So the ones that give us a difference of 2 are 5 and 3. So I'm going to put my variable with a 3, that forms one binomial, and my variable with a 5, that forms the other binomial. And then I'm going to look to the sign here to tell me what the sign of the larger factor is. So 5 gets a negative, and then the other one gets the opposite, a positive. And that's how I'm factoring those. Now moving on to my next one. Again, factors of 6, 1 and 6, 2 and 3. And then we're looking for the ones that give us a difference. So I want the difference this time to be of a positive 1. And so that's 2 and 3. So I'm going to need an x with a 2. And oops, I kind of said that was 3. So let's go with that, x with a 3 and x with a 2. And then I want this one to be positive. So the larger one gets positive sign, and then the smaller one gets a negative. So we have x plus 3 times the x minus 2. And then moving on to the last one, again we have, interesting, let's see, x minus 6. That was that one there, and here's the next one. Our next one here is 72. So we have factors of 72, 1 and 72, and we have 2 and 36, and we have 3 and let's see, 24, and we have 4 and 18, and 5 doesn't go into it, and 6 and 12, 7 doesn't go into it, and 8 and 9. Wow, that was a long list of factors, right? But that's what we need, and we need the ones that sum to 17. So the ones that sum to 17 are the ones that would have been obvious to us, right? 8 and 9, but don't always just assume they'll be the obvious ones. And so we have an x with an 8 and an x with a 9, and then we're going to use this sign for both of them because that was a sum. So this is a minus and a minus. So we have x minus 8 times x minus 9, and that's how that factors. Now our next one, we've got a y again. So remember, we're going to check this x here hung around in the middle, and this y here hangs around in the middle, so excellent. So we're just going to put two binomials, and we're going to make sure there's a y in the second term, and there's an x in the first term. And now we'll just factors of 4. So we have 1 and 4, and we have 2 and 2. And we want the factors that give us a difference of 3. So difference of 3, yep, 1 and 4. So we'll put a 4, and you can put a 1 or you can just leave it as a y, whatever makes you happy. And then the bigger one goes with the bigger number here, or bigger sign. And then this one is the opposite. And there we go, that's how that one factors. Now moving on to our next one. The problem with this one is that it is something called prime. Remember, you can have prime numbers, right? So if we have a prime number, we have 5. And prime numbers, the only way to make a prime number is a number, the number itself times 1. Well, that's the same with a prime polynomial. So let's take a look at this. So we need the factors of 5. 1 and 5 only, right? And we need those factors that sum to 7. Well, these can't sum to 7. 1 plus 5 does not equal 7. And therefore this isn't going to factor. And that's when we say that it's prime. If something doesn't factor at all, the only thing that we can do with it is write 1 times the polynomial itself. Then we call it a prime polynomial. All right, now the next section we're going to do is when we have a GCF as well as factoring a trinomial. And this, of course, Lehman covers in section 8.2, but I wanted to break down just the GCF and then apply it to factoring a trinomial. So we'll do that next.